Let P of x, y be a point in the plane that forms an angle theta with the positive x-axis. Let the distance from P to the origin O be given by R, and let the side PO be the terminal side of the angle theta. Alright, so here we have our triangle, the origin, our point, we have x, y, and this angle here is theta, and R is our hypotenuse. For any point x, y in the plane, cosine theta equals x over r, and sine theta equals y over r, where x squared plus y squared equals r squared, the Pythagorean theorem, and r is greater than 0. And theta is the standard angle in degrees whose initial side is the positive x-axis and terminal side includes the point x, y. For any point x, y in the plane, cosine of theta equals x over r, and sine theta equals y over r. Solving for x and y gives the following. X equals r times cosine theta, and y equals r times sine theta. The slope of the terminal side joining P and the origin O is m equals y over x, which is r times sine theta over r times cosine theta. Sine theta over cosine theta is tan theta, and the r's cancel out. The sine, cosine, and tangent functions were introduced in geometry. In pre-calculus, 3 more trigonometric functions are added to the mix. Alright, so for any point x, y in the plane, the cotangent function is given by cotangent theta equals x over y. So tan theta times cotangent theta equals 1. The secant function is given by secant theta equals r over x, so cosine theta times secant theta equals 1. And the cosecant function is given by cosecant theta equals y over r, so sine theta times cosecant theta equals 1. Note each of the new functions is a reciprocal. Let P of x, y be a point in the plane that forms an angle theta with the positive x-axis. Let the distance from P to the origin O be given by r, where r is greater than 0. Alright, so our 6 trig function values. For any point x, y in the plane, the 6 trig function values are sine theta equals y over r, cosine theta equals x over r, tangent theta equals y over x, cotangent theta is the reciprocal of tan theta, and that's x over y, secant theta is the reciprocal of cosine theta, and that is r over x, and cosecant theta is the reciprocal of sine theta, and that is r over y. Let P, -4, 3 be a point in the plane that forms an angle theta with the positive x-axis. Let the distance from P to the origin O be given by r. Alright, so we have our point here at -4, 3, so the x value here is -4, the y value is 3. So here we have our 3, 4, 5 triangle, which is a special right triangle. But our 6 trig functions are going to be sine theta equals y over r, so that's 3 over 5. Cosine theta is x over r, so that's -4 over 5. Tan theta is y over x, so that's -3 over 4. Well, it's positive 3 over -4, but the negative sign moves to the front. Cotangent theta is x over y, so that's -4 over 3. Secant theta is r over x, so that is 5 over -4, or -5 over 4. Cosecant theta equals r over y, which is 5 over 3. Let P, 5, 12 be a point in the plane that forms an angle theta with the positive x-axis. Let the distance from P to the origin O be given by r. Alright, so we have our point way down here at 5, -12. And so here we have sine theta equals -12. Here, let's fill this in. So the x value here is 5, and the y value here is 12, or it's -12, but this length is 12. And we have the r value of 13, since this is a 5, 12, 13 special right triangle. So we have sine theta, and this is theta here, is -12 over 13. We have cosine theta is 5 over 13. And we have tangent theta equals -12 over 5. So cotangent theta is the reciprocal of tan theta, so that's going to be -5 over 12. Secant theta is the reciprocal of cosine theta, so that's going to be 13 over 5. And cosecant theta is the reciprocal of sine theta, so that will be -13 over 12. And there are the answers.